Today's lesson, we're going to be talking about multiplying and dividing rational expressions. So as a little do now, just a little reminder of how to multiply or divide fractions. So when you're multiplying fractions, you're really multiplying across, right? So here it's 2 times 6, and it's 3 times 11. But the problem here is I might have been able to reduce this. I know I can definitely reduce 12 over 33, and it's harder to see now. So what I could have done is I could have said 6 is really 3 times 2. So the 3's canceled, so it's really 2 times 2 on top, and just 1 times 11 on the bottom. And that would be my simplified form. So as long as you get to the simplified form at the end, that's fine, but sometimes it's easier to factor it out first. Right here, we're dividing. So remember, dividing is the same as multiplying by the reciprocal. So if I flip 8 over 25 over, now it's times. So it could be 8 times 25 and 15 times 8, but also an 8 and an 8 will cancel out on the bottoms. 15 is really 5 times 3, and 25 is really 5 times 5. So a set of 5's cancel. So we're left with 1 times 5 on top, 3 times 1 on the bottom. So 5/3 was my answer. Also remember factoring. When it's the difference of two cubes, right? This is really 8 being cubed, and this is really 2 being cubed. We have our special pattern. That's x minus 2, then the x squared plus the product, 2x plus 2 squared, which is 4. And for our last one here, we have a number in front of the x squared, so that would be 5 times the 12 first to get 60. We would go through all the factors of 60 till we found the ones that were equal to 32. So I see that that's 30 and 2, right? 30 times 2 is 60, 30 plus 2 is 32. Then we write it out as our 4 terms, right? 5x squared plus 30x plus 2x plus 12. Factor that by grouping. So out of the first two, we have a 5x. Divide that, we get x plus 6. Second two, I have positive 2. Divide that, we have x plus 6. So the factored form would be the x plus 6, and then the leftover is the 5x plus 2. So now getting into the multiplying and dividing rational expressions. So we're going to factor the numerator and denominator first. We're going to cancel out any factors that are common to both the numerator and denominator. And we will note any excluded values from the original expression, right? What could x have not been at all? So already from the original expression, x can't be -1 and x can't be -3 because those would both make the denominator 0. But if I look at my factors, right? Factors being terms that are being multiplied by each other. I have an x plus 1 as a factor on the top and an x plus 1 as a factor on the bottom. So those factors would cancel out. And I'm left with x plus 5 on the top and x plus 3 on the bottom. Now, a lot of you are going to try to cancel out these x's, but that's not allowed because the x is not a factor. It's x plus 5, right? That's an addition. That's not a multiplication. You can only cancel out things that had been multiplied by each other. So this is actually done. That is my simplified expression. And those are my excluded values. All right, example 2, we're just going to simplify this rational expression and state any excluded values. So I need to factor this first. So what multiplies to -12 and adds to -4 is a -6 and a +2. This is the difference of two squares, right? X being squared and 2 being squared. So that's x plus 2, x minus 2. So from my original expression, x cannot equal 2 or -2. But I'm able to cancel out the factors of x plus 2 on the top and bottom. So what I'm left with is x minus 6 over x minus 2. And in B, if I were to factor the top, this just has a GCF. We could take x out, and we're left with x plus 9. On the bottom, I have x squared. If I wanted to write that out, that's really x times x. It might be easier to see it that way. So already I know that from the original, x cannot equal 0. but I also see that I can cancel out a singular x here, right? There's an x in both places. This was being multiplied by something else, so that's why it's able to be canceled out. So I'm left with x plus 9 over x. Here's one for you to try. You can pause. The answer is posted in the blank notes on Google Classroom. So when we multiply rational expressions, we're going to do all those same things, but we're going to factor everything so that way we can cancel things out, right? So the top is a times c, the bottom is b times d, but overall, anything on the top can cancel out with anything on the bottom, right? So the example that they gave here, 5x squared times 6x cubed, they actually did the multiplication, but 30 is really 10 times 3, x cubed is really 3x's, y cubed is really 3y's. The bottom, we had 20, so 20 was really 10 times 2, and then they canceled the 10s, right? The x just existed. We canceled one of the x's. We were still left with 2 of them. We had all 3 y's to cancel, and that's how this works, right? And then from the original, x couldn't be 0 and y couldn't be 0. For these, we're just going to worry about finding the product. We're not going to worry about stating the excluded values, but it's still possible that we're asking that question here as well. So what I'm going to do is I'm going to make sure all 4 parts are factored, right? So this 3x squared minus 3x has a GCF of 3x in it. And then I'm left with x minus 1. And I'm just going to keep going across the top, and I'm going to factor this part as well. So times to negative 20 adds to positive 1 would be x plus 5 and x minus 4. So that is my numerator all factored out. I'm going to do the same thing for my denominator. To multiply negative 5, add to 4 is positive 5 and negative 1. And then we just had the 3x. So a 3x will cancel with a 3x. An x minus 1 will cancel with an x minus 1. And an x plus 5 will cancel with an x plus 5. So all I'm left with in this problem is x minus 4. That is the product of those two fractions. All right, another one together. So here, when there's nothing over it, we could say it's over 1, right? Or there's nothing under it. So the top can't be factored any further. That's just x plus 2. And this, nothing multiplies to 9 and adds to 3. So that's just x squared plus 3x plus 9 over. Now this is the difference of 2 cubes, right? That's x being cubed and that's 3 being cubed. So using our special pattern, that's x minus 3, and then the first term squared plus their product plus the second number squared. And now I see that I have an x squared plus 3x plus 9 in both places. So what I'm left with is x plus 2 over x minus 3. Here's something for you to try. You can pause. Answers are in Google Classroom. To divide, just like we divided our fractions before, we multiply by the reciprocal. So we're still going to follow the steps of factoring everything, but we're going to have that second fraction as a reciprocal. So here, we have a few ways of how we write out the work. Sometimes I factor them first and then flip them. Sometimes I flip them first and then factor, whatever you're most comfortable doing. So for my first fraction, 7x can't be factored further, right? That's just 7 times x. And now I'm going to factor this part, right? I'm going to factor the bottom and put it on the top. That's how I'm going to approach this problem. So what multiplies to 30 and adds to negative 11 is x minus 6 and x minus 5. So that's my new numerator, right? Because I'm multiplying by this flipped. For 2x minus 10, that's a GCF of 2, and I'm left with x minus 5. And then we had this top part that's going to the bottom, so x squared minus 6x also has a GCF of x, and I'm left with x minus 6. So for this one, an x will cancel with an x, an x minus 6 will cancel with an x minus 6, and x minus 5 will cancel with an x minus 5, and this is it, 7 over 2. All right, for B, So I'm dividing by this one thing, which means timesing by its reciprocal. So timesing by 1 over that. So 6x squared plus x minus 15. We have to factor this first. And this one requires a little bit of work. So we have to start with doing 6 times negative 15 to get negative 90. Then we would look for what multiplies to negative 90 and adds to positive 1. So that would be 10 and negative 9. So this one plus 10x minus 9x minus 15. There's a 2 in these and an x, and we're left with 3x plus 5. There's a negative 3 in those. We're left with 3x plus 5. So this part right here factors to 3x plus 5 times 2x minus 3, right? Times now the 1, so we don't have to put that on top. Bottom, we had 4x squared. And then out of this, I have a GCF of x, and then that leaves me with 3x plus 5. So the 3x plus 5's cancel. That's all that cancels, so we're left with 2x minus 3 on top. And I am actually going to simplify this because these are factors that can combine. As long as it's not like a binomial, I'm actually going to combine them. So 4x squared and x is 4x cubed. All right, that'll be the only time I really simplify the denominator like that, when it's an x times an x that's left. All right, another one. So this one's quite complicated because we have this fraction has to be flipped, right? We're going to flip this over. Let's turn it into times. And this one has quite a bit of factoring to go on with. So I'm going to start with this one here. So we're going to start with 3 times negative 80, which is negative 240. The numbers that multiply to negative 240 that add to negative 22 are negative 30 and 8. So this is going to become 3x squared minus 30x plus 8x minus 80. 3x comes out of these, left with x minus 10. 8 comes out of these, left with x minus 10, which means I'm able to now factor this. All right. Piece by piece here. This top part, there's a GCF of x, and 27 and 72 both have 9 going to them. So that's 9x. So that's 3x plus 8. The rest of my top, right, is this part here. There's also a GCF there of 3. Nope, sorry, 2. And what I'm left with is 3x minus 4. So that's all of my numerator numbers. Denominator, so here there's again a GCF of x, and 2736, again that's 9 that goes into both. So that's a 3x minus 4. And then from factoring that before, we have x minus 10 and 3x plus 8. So the 9x's cancel. 3x plus 8's cancel. 3x minus 4's cancel. And I'm left with 2 over x minus 10. One more together, even more complicated. Thankfully, this one's not as bad to flip over, but we do have 2 to factor and with quite large numbers. Ooh, hitting so many buttons. Okay, so starting with this one, 7 times 100 was 700. 70 times 10 gives me 80. Well, it gives me 700, and adding them gives me 80. So that's going to be 7x squared plus 70x plus 10x plus 100. 7x out of those, left with x plus 10. 10 out of those, left with x plus 10. Then for this one, we're going to start with 49 times negative 30. This is a big one, negative 1470. Looking for the numbers that multiply to negative 1470 and add to 49. We could be here a while. That's why I already did it ahead of time. Negative 21. That's not how you write negative 21. and 70. So those add to 49. So we're going to have 49x squared minus 21x plus 70x minus 30. So these have 49 and 21, 7 goes into both, and x goes into both. We're left with 7x minus 3. 10 goes into both of those. We're left with 7x minus 3. All right. So for this part, that was x plus 10 and 7x plus 10. I'm actually going to put my denominator, already start that, because I know that this is 7x plus 10 and 7x minus 3. And flipping these, this one here, what was originally the denominator, has a 3 in common. We're left with 7x minus 3. And this one, which was originally the numerator that's going in the denominator, has a GCF of 3. And that's left with x minus t. All right. Now for some cancel-ins. We have a 7x plus 10 and a 7x plus 10. We have a 7x minus 3 and a 7x minus 3. We have a 3 and a 3. So what I'm overall left with is x plus 10 over x minus 8. There's some last ones here for you to try. You can pause or end the video. The answers are posted in the blank notes on Google Classroom. And that is the end of multiplying and dividing rational expressions.